Okay, we are going to talk now about using a class, developing sort of a more complicated class than we've sort of looked at thus far. The code's not longer than, for example, Circle, but I'd say the ideas in it are a little more subtle. And so I want to work through this fairly carefully. And again, you should try to work out some examples by hand for the kind of different operations we're doing, and just work to make sure you understand the concepts in a clean way that will help us code things later. So we're going to practice developing classes. Again, this object-oriented style is new and different. So far, we've looked at a circle class, and sort of two forms of it, and fraction class, and again, been adding different things to it. So hopefully you're getting the basic idea of, again, a class holds data, instance variables, operations on the data, methods, and we make instances of the class and ask those instances to do things through the methods. And again, that the data inside the class is basically hidden from view. We don't have to know how it's stored. All we care about are the methods available to us and what the class says it can do for us through that public interface. Then the other thing is that really, what is the point of classes? Well, we're trying to develop new types. So you make objects of the class you write, and then in some ways you can think of as extending the Java language to do new and more powerful things. And when you write a larger project, you're basically making a bunch of classes that define new kinds of operations for you, and then you use those things as sort of just part of this larger Java style. All right, so we've been using arrays now for quite a while, and hopefully you're comfortable with them. The idea that you have to make a new array and you index into it to get the elements of the array, and you can assign new values into those elements, and you can pull them out and so on. But hopefully, as you've been using them, you've been thinking there's like a big problem with Java arrays. And unfortunately, we're not in class right now, so I can't exactly ask you what you think that big problem is. But if you spend a minute thinking about it, I hope you come to something like they are a set size. And it's sort of frustrating, right? Like you build it and then you're sort of stuck with it for forever. Now, again, a couple lectures ago, we were reading lines from a file, and it was sort of awkward in the sense we had to know how many lines were in the file to begin with. And like, wouldn't it be nice just to read a line and then say, hey, add it to the end of this thing that grows as we get more information. And in fact, that's a pretty well understood thing. This thing, it's often called the dynamic array. And you just want this thing that acts like an array, but you can say, hey, make more space for me, and I'm going to add another element to it. Now, so the problem is, we're kind of stuck here. So Java defines what an array is and says this is something that's a fixed size. And so, how can we where can we store this information if not in an array? Well, that's a very good question. So the basic approach is we're going to write a new class. And this class is going to be something that defines what a dynamic or variable sized array is going to look like. And in that class, we are going to hold an array because we need some place to store data. And then the thing is, how do we actually then change the array? Well, to grow the array, we're going to make an array that's one bigger. So just as a local variable, right, this new array or something. And then we're going to copy all the values over from the old array. And then we're going to add the new value on the end in this case, I guess. And then we're going to say, hey, instance variable, now you're referencing this new array, right? So even though we can't change an array, we can change what is assigned to an array variable. And so we can assign a new larger array as we need more space. So if we think about this in an object-oriented way, again, there's sort of questions about how you think about a class, and typically you think about what data is stored, and in this case it's an array that is stored. And then what are the operations we want? Well, we want to get an element out of the array, we want to set an element in the array, just like a normal array, right? We want to be able to do those things. But then there's new things we want to be able to do. We want to be able to add an element to the end, and maybe we want to insert an element at some location, like at an index value. So the meaning there would be that we push everything over a little bit and then create a space for the new one and put the value in there. And so again, there's this sort of design process where you're thinking about, okay, this is a new kind of array. We want to keep some of the old values, but like, what are the new things we want to do? And it's important to kind of think through that kind of carefully before you sort of jump in and start to code. So let's look at an example of like what it would look like to add a value at the end of an existing array once it's already filled up, right? We've already put values everywhere. So we talked about having some kind of instance variable that stores the data, and maybe we'll call that instance variable data, right? This is the thing that's inside the array. And let's say right now it has a space for 4 elements, so it's an int array of size 4, and it's all full up. And we want to add a value 10 to the end, right? So we're not saying put 10 where the 2 is, we're saying make a new space and put the 10 there. So again, the way we're going to do this is we're going to make a new array of size 5, like called new data or something like that. And it's going to be default initialized to zeros because that's what arrays are, how they behave. We're going to copy the values over from the old array. So we're going to loop over it, and just copy it from the index in the old data into the new data. And then we're going to add the 10 on the end. So at this point, the object has this instance variable data that points at the old array, and there's this new local variable, new data, that is pointing to the new array that we kind of like. We like this new one. So all we do is assign this new array to the data instance variable, and it basically forgets about the old one, and now thinks it's a size array of size 5, and has all the values we want. So again, the trick here is that we can't grow an array, but we can make arrays of different sizes, and we can assign an array variable or instance variable to that new array. So we basically throw out the old array and remember the new one. There's quite a bit of work involved in that to make that happen, right? Now, adding to the middle is a little trickier. And again, how do you say where you want to add it? Well, we know about locations in an array. It's the index value. And so we would say like add value 10 at index, 0, 1, 2, 3, 4, depending on what, and what that means is we're going to still create an array that's 1 bigger. And then we are going to copy over all the old values that are before this insertion point, right? That looks exactly the same. And then we basically copy over the values above the insertion point, but shift them up by 1, right? So we go from index 4 to index 5, and index 5 to index 6, and so on. And so we're sort of in a little diagonal copy here where we're sort of putting them up 1 space ahead. And then we basically have a space free in the middle, and we add that location there. So this isn't really that different from the end. It's just that instead of just copying from below it and then inserting at the new location, there's another phase where we have to also copy above that spot in a shifted way. Right? So these two things are really the key to how all this is going to work. And again, you have to kind of do this by hand once or twice to convince yourself that you know what you're doing, right? Don't just look at that and think like, it looks pretty good. You have to kind of work through it and draw these little boxes and pretend to copy these values over and see what it does in order to figure out how to code this. All right, so let's code this. Maybe I'll stick the slide here so I remember what we want, right? So, okay. Sometimes I keep wanting to start in main, which is not right. That's where we're going to maybe test this dynamic array. So again, first we're going to make our instance variables. And again, you wouldn't normally write this kind of comment in your own code because it's like sort of self-explanatory, but I'm just trying to make sure we all understand where we are in this process. And so, first of all, what is this dynamic array going to hold? Let's see. So we should hold. I guess I'm holding ints. Okay, we'll do an int. So this defines whether this new thing holds like ints or strings or whatever we want to do. So okay, so int array data, and we don't set it filled with anything yet, right? We're just saying that this thing exists as an instance variable in every instance of the class. So when we make a new dynamic array somewhere, that it's going to have its own int array data stored inside it. All right. Okay, so we only have that instance variable. We don't have that much in here. Now we have to make a constructor, dynamic array, and I'd say it doesn't have to, you know, we don't just start with anything, right? We can start with just an empty array, it has no values in it, and then we just grow it as we need it. So we're not, you know, like, we could do it like a normal array where you say how big you want it to be when you start off, but we don't have to do it like that. All right, so what's the job here? We're going to assign to data a new int array of size 0. All right, we got to start somewhere. And again, there's no elements in there yet, so but that's fine because we have the confidence we can add them as we need them. All right, so now let's look at the hard part is going to be adding these things and growing the array. Let's look at setting and getting the values out of this array. We want it to act like a normal array. In other words, you pull values out, put values in. All right, so I'm going to have a public. This is going to be the getter. Get a value. So when we get a value out of this dynamic array, it's going to be something that's stored in this int array data, and it's going to be, I want to get an int out, right? So I say give me the value at location 5, and that's going to give me some int back. We're going to return an int, and I'm going to just call this get element. And to get a value, what do we need to do? We need to say where we want to get it from, all right? So this is going to be kind of like a Java array when you have this like square bracket notation, and the index is inside it, and that gets a value. In this case, we have to give it a named method in the class. We can't somehow make those square brackets work for us. Other languages, there are ways to do that. C++, for example, allows you to do what's called overloading an operator, and then basically say, hey, for this class, make square bracket act like this. But Java, they don't want to do that. Okay, so what does this mean? Well, we're going to basically return the index that's at data. So it's not that hard, right? We're basically mimicking or mirroring what's going on in the underlying array through this public interface. Now, here's the thing. What if we want to protect ourselves with some sort of exception? So what if we give it like a negative index or one that's out of the range? Well, I can say if index is less than 0, or the index is greater or equal to the data length. In other words, you got to remember that the valid index values you can use with an array is from 0 to the length minus 1. So if it's less than 0 or if it's equal to the length or greater, that's a problem. And I'm going to throw a new index out of bounds exception. And we're going to say that, hey, it's your responsibility if you want to check for that to try and catch it. But at least we have that protection in there where it's not our class's fault for crashing anymore, right? It's the program that's using us that has to have some responsibility. Now, the other thing I'll note here is that in some ways this is a little redundant. If you use an index out of bounds here, it will throw its own index out of bounds exception. But for example, we could give a message here that maybe is a little more clarifying. Dynamic array index out of bounds. Not that much more clarifying, but right. Okay, so we want to somehow, again, protect ourselves by doing this sort of correctly. Let's, well, we can't do much yet because we can't really test this because it's always a size 0. Right now it's stuck at size 0. But we can still sort of, again, imagine we want a setter, set element. And to set an element, we have to say where we're setting it, at what location, and what the new value should be. And this isn't one that's intended to grow it. This is just one that says for an existing valid spot, here's how we should change it. So I'm going to give the location first, some index, and I'm going to give a new value. And basically we just need to say that data at index is equal to the new value, right? Sometimes these things aren't hard. They're just sort of, you just have to track what's going on here. And again, I could, oops, I could add in this throw to indicate if you're asking for any legal index. Okay, get an element of the array, set an element of the array, add an element to the end. Let's do this insert an element at index. Okay, so what does that mean? It means we're gonna take a location and a new value, and again we're gonna copy everything up to where that value, that index is, then we're going to push everything past it up by 1, and then we're gonna put that value in that new spot. And so it's a multi-stage process here, right? Okay, so this is also a public method, and we don't return a value, we're changing the internal state of the object to have a bigger array. Okay. And I'm just going to call this, well, I'm going to call it insert, I guess. Insert value. I don't know. And again, this takes a location, and it takes a new value. So it looks a lot like set, but at least the way it's set up, but the behavior is different. This one is actually going to grow the array. All right, so in some ways we need to look at the steps here. We're making a new array that's bigger. We're going to copy the old values over, either in the same spot or pushed over a little bit. And then we're going to set this data instance variable to be this new array, right? And again, this is sort of a tough, I won't say it's a tough problem, it's a complicated problem, and it's important to break it into those steps so you can think about which step you're working on when you're coding, right? And so, again, sometimes it could help here to make a new larger array, sure. Okay, so we're gonna have this int array new data, and it is a new int array of a certain size. Oops. And what size should it be? Well, it should be the length of the old one plus 1, right? If it was size 2, you want it to be 3. If it was size 5, you want it to be 6. So we're taking the old size and adding 1 to it and making a new int array that's that new bigger thing. And again, there's nothing in here, just default values of 0. And so our job is to make it look like the array that we want, right? By copying stuff and so on. Index, yeah, okay. So let's kind of remind ourselves of this process. We want to copy over the old values before the index. Okay, so I can do that, right? We just need a loop. So for int, now I have index and index. That was sort of a, let's call this one insert index. How about, that's the more specialized one, right? So here now we can have index equals 0, and we want to copy up to, so again, let's say we want to say put it at location 4, 0, 1, 2, 3. We want to copy over, and then there's going to be other stuff that happens later. So we're going to go from 0 up to this insert index. So when it hits 3, if we were inserting at 4, it'll go from 0 to 3. And index plus plus. And I'm going to say that the new data at index is equal to the old data at index. And that's all we're doing. We're taking these values and copying over to the new location. Then I want to actually put in this new value at the index spot. So new data at insert index equals new value. Brain's running out of power here. Okay, so we made, let's comment this, just keep track of where we are. Copy values below insert index. Add the value at insert index, and then copy and shift values above insert index. Again, we've taken over this spot. So if I copy the value at the old value at location 4 and put it in location 4, it would cover up that new value we're trying to stick there. So we're taking it at the old value for location 4 and putting it at location 5. We're shifting it up by 1. All right, so here we need another loop to kind of finish this off for int index equals, and now we're trying to decide, am I looping over the old values and then putting in the new, or am I looping over the new values and getting it from the old? I think I want to loop over the old values and then figure out where to put them. So I want to go int index equals insert index. We're starting at location 4, this value here. And what's all complaining about here? We'll see. How far do we go? While index is less than the length of the old array. And I'm going to add one to index. Okay, I guess it was just fussing because the for statement wasn't fully legal there. So I want to take new data at index plus 1, in other words, this spot, and grab it from the old one at index, right? So we're sort of shifting it over, oops, equals data at index. And okay, so at this point we've created this new array that's one bigger and hopefully has all the values that we want it to be like. And all we have to do now is assign the new array to the instance variable. In other words, keep track of it again. Otherwise it goes away when we leave the scope of this method here. So I'm just going to say data equals new data. Assign this new array to this data instance variable. All right, so again, this is a bit of a complicated method, and to be honest, it takes a while to work out the first time you do it, for sure. And so don't be alarmed that it seems like I was just going through these steps and typing in code. It took me some time to kind of figure out exactly what I wanted to do. Again, by kind of thinking about it, writing it out by hand, and then trying to break it into a few steps, and then keeping track what step I'm working on. And at some point, a step turns into a loop or an if statement or something like that, and you just go ahead and you can code it. And then there's some sort of fussy thinking about, where you are exactly in this thing with the index value. So again, we make a new array that's one bigger. We copy up to the insertion point, copy values over from data to new data. We add the new value in at the insertion point. And then above the insertion point, we take the old values from the old array and stick them one higher in the new array, because they need to be moved over to make space for this new value. Now, we should actually use this thing and see what happens, right? So here, I'm going to make a dynamic array vals, and it's equal to a new dynamic array. This has nothing in it yet, right? So we need to, what do I call it? Insert value. Take vals, and I'm going to ask it to insert a value. And we can't stick it anywhere. I can't say stick it at 1,000. It has to be basically in the existing array or a new one at the end, right? So I'm going to say insert a value at 0. This is the location. and I want to put a 10 there. Now, it would be nice if I could see what's going on. I think this will run, unless I made some mistakes. Kind of good to check things out, right? Okay, nothing prints, nothing, there's no output here. It'd be nice to print something out and just sort of see what's going on here. So to do that, I should make a public string toString of this, and I should just return, let's just return the arrays toString of data. And I have to import this. Maybe it's happy. All right. Let's try to print out vowels. Yeah, flash by. Okay, so there's now a 10 value. It was empty. At location 0, we put a 10, and now it looks like this. So that's cool. It looks like it's kind of working, right? Let's insert at 1. In other words, at the end of this thing, let's put it 20. So it's grown, right? Now notice, again, the array hasn't grown. We're doing some kind of sleight of hand, some magic underneath inside the class here that's hidden from us that says, if you want a bigger array, okay, let's make a bigger array and throw out the old one. Now the other thing we should check is that, can I now stick one at the beginning and have that work, right? So before I was sort of adding the 0 location, here's 10, adding 1 to it, 20. Now I'm saying push those over and put 30 at the beginning. Hey, looks like it works, right? So in some ways, we have now taken Java and made it a ton better. We have this new thing, a dynamic array. It grows as we need it. We could have made it for strings if we wanted to read lines from a file and stored strings in there. But basically, we have this new powerful thing that that satisfies a lack that we saw in the language. Now, I will say there's something called an array list we'll get to very shortly. Java has figured this out as well, and they have their own object that does this, their own type that does this. So it's not like we're going to get a Nobel Prize for this or anything like that. But I want to point out, someone, when they were writing Java, sort of took simpler parts and put them together to make more complicated parts. And we can do the same thing and basically make our own new complicated parts that we can use in our code as we see fit. So again, we'll be working with this a little bit more. You should try to see how this code works, especially this insert value part. Has multiple steps, but again, if you break it into pieces and just think about it one at a time, it kind of allows us to get through it without getting overwhelmed by the complexity. So again, that's an important skill to work with on your own, to be able to look at a little more complicated things and like summarize it into like one line. What's going on here? What's going on here? What's going on here? And then at some point you can check all these things to see what's actually happening as it runs and see if it does what you think what you think it's supposed to do. All right, so that's it. But again, we'll be working on this a little bit more. This is a big project for us.